Assalamualaikum. We are trying to find out the H matrix for rigid motion. These H matrices are very important to find for the rigid motion when we are applying KLT tracking alignment. We want to align the motion vectors in the consecutive frames, and we want to do tracking with the help of KLT algorithm. So first of all, you need to understand that rigid motion is a type of motion in which the object is translated. By translation, I means that the object is moved linearly by some linear factor in x-axis and some linear factor in y-axis. And apart from translation, the object is also rotated at some angle. So the equations that we use for rigid motion tell us that the new coordinates of the object include x cosine of theta minus y sine of theta plus b1, which is the linear translation, and y coordinate is equal to x sine theta plus y cos theta, with b2, which is the linear translation in y-axis. If you want to write down these equations in and you want to represent this motion with a vector function, then we say that this vector function is defined in some parameters p, and you can write this vector function in the form of these two sub-functions. This first equation becomes the first sub-function f1, and this second equation becomes the second sub-function f2. It means that your motion can be represented in the form of two vectors f1 and f2, and these two vectors have certain angles, and they depend on these translation parameters. So this is a vector function for the rigid motion. Now if we want to find out the H matrix, the steps that we need to do is that we have to first of all find the Jacobian matrix. You know that the Jacobian of any vector function is equal to the partial derivatives of that vector function with respect to all those parameters in which that vector function is defined. So since this rigid motion is defined in two sub-functions f1 and f2, so we will take the partial derivatives of this first sub-function f1 with respect to the parameters that are present in it. So first parameter is this theta, second parameter is this b1, and there is a third parameter b2. So we will take partial derivatives of the first function with respect to these three parameters, and in the second row we will take the partial derivatives of second sub-function with respect to these parameters. So if I do derivative with respect to theta for this sub-function, I will get x, cos will convert into minus sine theta, and y will come as it is, and sine of theta will become cos of theta. So I will get minus x sine theta minus y cos theta for this first sub-function. Now I'm going to do the partial derivative of this first function with respect to b1. So this term will generate 0, this term will generate 0, and this term will generate 1. Now I will do the partial derivative with respect to b2. Since there is no b2, so I get 0. Okay, now for the second sub-function, x will remain as it is, sine of theta will generate cos theta when I do the derivative with respect to theta. Y will come as it is, and cos of theta will generate minus sine theta. So I get this second term in the second row, that x cos theta minus y sine theta. And when I do the derivative with respect to b1, I will get 0, 0 and 0 for all these three terms, and so this is the 0. And when I do the partial derivative with respect to b2, I will get 0 for this term, 0 for this term, and 1 for this term. So this is my Jacobian matrix for this vector function w. Now the next step that we want to do in order to find the H matrix, the Hessian matrix, we want to find the gradient of I, the gradient of the image, that what are the partial derivatives in the image with respect to x-axis, and what are the partial derivatives in the image with respect to y-axis. The combination of these two partial derivatives of the image are known as the gradient of that image. Gradient also tells us about the edges in that image. So now I am going to multiply this gradient with the Jacobian matrix. So when I multiply this gradient with the Jacobian matrix, Simply you know that this is a 1 by 2 matrix, it has 1 row and 2 columns, and this is a 2 by 3 matrix, it has 2 rows and 3 columns. So this 2 is matched with this 2, which tells us that yes, multiplication can be performed, and the answer that I am going to get will be a 1 cross 3 matrix, which will have 1 row and 3 columns. So when the first term of Ix is multiplied with this, I will have Ix with the first term, Ix minus x sine theta, and Ix minus y cos theta. And when this Ix is multiplied with yes, it has multiplied with this first term, and then this term will multiply with this, because whenever we do matrix multiplication, we move in a row and we multiply in column. So this term Iy is multiplied with this x cos theta minus y sin theta. So I get Ix minus x and this Iy with this x. So this is one term. Okay, now I am going to do the multiplication with this row. So Ix is multiplied with 1 and I get Ix, and Iy is multiplied by 0, so I get a 0. Now I'm going to multiply this row with this column. So Ix is multiplied with 0, so 0, and Iy is multiplied with 1, so I get I1. So basically it is a single row, 1 row and 3 columns, first element, second element and third element. Okay, so now the next step we want to do is we have to take a transpose of this multiplication product. So when we take the transpose, this matrix will simply transform from a single row to 3 rows and 1 column. So the first row will be this first element, the second row will be this element, and the third row will be the third element. Now in order to find out the Hermitian matrix, we know that we have to do a product of these two terms. Hermitian matrix is actually a product of this transpose multiplied with this. So I am going to solve this for you on this board. Okay, so how we are going to do that? So first of all, we have this transpose, which has I of x minus x sine theta minus y cos theta with I of y with x cos theta and minus y sine theta. This is the first term, the second term is Ix, and the third term is Iy. Okay, so this transpose is going to be multiplied with this vector. So when we multiply the first term with the first term, what we are going to get is, we will simply get an Ix square and minus x sine theta minus y cos theta square and Iy square, and this x cos theta minus y sine theta square, because same terms are being multiplied. This is the first term is again multiplied with this same term, so we will simply get the square on all these terms. Whenever you do matrix multiplication, you know that the first term will be multiplied with the first term, and then this first term will be multiplied with this second term, and then this first term will be multiplied with the third term.